Everyone, and welcome to another episode of AI Climbing with Sheikh. And as we will continue our journey to understand a bit how you can build different tools and use them for the different data processing and AI models, right? The TensorFlow becomes one of the key approach or methodology or framework, what you ever call it. But the way I want to start, right, you have seen the earlier sharing with Spark, and then there is a TensorFlow, and then definitely there is a PyTorch from Facebook. But TensorFlow really stands out because that's the native way in the NVIDIA and those GPU processing is quite efficient in a way. Lot of libraries like CUDA and others are inbuilt into it, and then as you will go towards the GPU virtualization, so it's pretty much becomes very important. And the way we will be conducting this session is first go towards the TensorFlow architecture and components, and then as we will evolve, we will touch on solving a problem with the classification of a fashion models and fashion data set. And yeah, let's now start in terms of what TensorFlow is and what are the different components. So that's pretty much a mathematical models, and as you can see in input tensors, we have a different inputs, right, which is coming from the data. So all of the data representing in numbers, right? And so these numbers are all multi-dimensional arrays, right, like representing the data in numbers. That pretty much what it is. And then the element wise operation is more like processing function. The first step is obviously a matrix multiplications, and then you will do the some sort of add subtract, how you will normalize and get the output of the functions. And so you really need to understand this box 2 and 3 as some sort of maths which is hidden in the model, and then you will do the tensor transformation. So before or after computation, we need to transform the tensors again, reshape them, transpose them, put some ReLU or scaling aspects into it, and then we will output the tensor, right? So that is pretty much how the whole architecture here works. And next into this, we need to understand the TensorFlow and the workflows. And as you can see over here, the natural first start is the preparing and process of data, right? So you start by preparing and processing the data, defining the feature columns, normalizing. So feature engineering, right? That's pretty much very important and crucial step. And then you will move towards the estimators or pre-built classifiers. And in TensorFlow, right, there are two options. One is inbuilt one, like the Keras and also Scikit, and so that actually helps you to integrate and talk via APIs. And then there are some estimators, right, which are the pre-built models or classifiers which you can use. So Keras or the pre-built classifiers. Then as you can see that there is a distribution strategy, like the whole idea is if you are running a large data set and you need a faster training, so you need to distribute it to multiple deep GPUs, and then you need to manage them, doing some resource efficiency like architectures like DRAs, and then you will save the model, right? And the way how the TensorFlow typically works, right? The save model is HDF5 format, right? And this is called the hierarchical data format. And then you can actually serve it, right? Like, so in terms of serving, you can actually serve the model in production environment either through APIs, which is how the Keras handle is, or you can deploy it as a package. You can integrate with app. For example, you can install directly on the mobile or edge devices, right? TensorFlow, Lite, and then again, you want to run it on the web. There are no lot of like TensorFlow JS and other mechanisms available in order to do it. So that's pretty much how it works. So you just need to understand the TensorFlow as well as PyTorch as the middle layer, right? Which runs on the cloud typically, and then it gives you all of those tools, right? Where you can drag everything in the workbench and make it work. So, yeah, that's is pretty much the thing here. Now, with this background, right, let's try to do a quick tutorial and how I will be like conducting it again. I have already run it and built it in a way, and you can. We will actually do a image classification task with the most famous fashion data sets, right? And if you see over here how we start, we install with some of the pre-built libraries, and then the next step will be to load some of those libraries. If you can see over here, right, the NumPy we will be using, TensorFlow, and then we will be using the Keras, right? So Keras has a number of data set inbuilt available, which it will directly instantiate and call, right? It can also load if you have a local data set, but I just used a very simple way, and this has actually contained 70, more than 70 gig, K Cray images, and classified into different classes. Class quantity is not too much, but yeah, it's a good starting point. And how it works, right? You will pre-process the data by normalizing the pixel and converting into integers. We also batch our data. So you can see over here, we are converting it into 28 by 28, I guess. That's how it's coming. But yeah, that's what it is. So you can see, right? We are putting the labels to the data, and then if you see over here, right, these labels here we are converting into integers, and converting images into the fixed data size, and then we are actually passing those images as well as the labels, right? So labels obviously needs to be in integers, and then applying the batch processing. So that's how we will pre-process the data, and the next step will be to visualize the images. It's very simple. I think the most simple way, right? Just matplotlib library in Python, and we will just actually plot. You can do any one, right, like randomly, and the number will change, because all it is doing, it is going into the data set, and it's actually trying to like see for a particular I think I need to run this also, since it is already we have done. So let's try to just go back, and why it is giving an error. All right, I have previously run it, and I think it's just some time, and it needs to reload everything. Maybe it's hibernate already, And let's try to continue. And as you can see that we will build the neural network with TensorFlow Keras APIs, and we will be applying different dash layers. As I showed you, right, the between input and output, there are a number of layers. And here what we are doing, from the start, we have a number of layers. First layer is 100, which is the, you can say, after input. Then a dense layer, which is again 50, and then the 10 is the third layer. And then naturally, for the output, we will be applying soft soft max, which is the last layer. And the next step is the compilation of the model. And as you can see again, we will be calling the model combine, calculate both the matrix and the loss using the Keras inbuilt function over here. And after that, we will prepare our test data set to evaluate the model. Is this pretty much straightforward thing, right? How we are going to do, you can see image and label, like just like what we did for the training data, right? And like if you go over here and remember something back, right, so you will find as when we loaded the model, right, it already had based on the data what we loaded, we already put the train as well as the test, you see over here. And we did something earlier for the training data. Now we will do the same thing for the test data. And then we will pretty much call this to the function, right, passing the images, and do the batch processing and return the results. So that's pretty much all what we are doing. And then finally, we will evaluate the model using the test data, number of metrics, and make predictions. And yeah, and that's how we actually do the build, train, and evaluate the models on this. Again, some important piece. This code is some baseline work shared by the ML AI solution architect team. And yeah, it is I like it in a way because it explains how you, through any data set, right, through the different phases, how you will train the model and tune it and test it in the way. And now I will go back and before closing, right, like it is very important that you understand this piece in a way that like how this TensorFlow or these different components of TensorFlow supports you, right? So it gives you the full workflow, right? Preparing the data set, defining the neural network. So I have showed you, right, multiple ways you can use it. There is a pre-built classifiers, DNN, and auto regressors and neural network, sigmoid, softmax, or you can call the Keras, for this. And then defining the loss function. So TensorFlow actually provides a list of loss functions, MSE, MAE, cross entropy, and all of others. And selecting the optimizers is important. So Adam is the most common one, but then we have SGD and others as well. And then you can evaluate the metrics, compiling the model, fitting the model. So as you can see over here, right, it's pretty much it will do the whole life cycle aspect of it. And the important piece is you can save the model, and normally it is saved in HDF5 format, and then you can serve the model, right? And TensorFlow is actually designed for the very large scale production grade data processing and capabilities for large scale data processing. And TensorFlow also provide a complete process of building those pipelines and managing this. So it has actually the TFX TensorFlow extended framework, which includes and integrates multiple components right from the whole ecosystem. And it's quite modular, scalable, and actually that's the reason many of the data scientists and AI people use it. And that's pretty much in a way I wanted to share. And it has lot of extension, including the one for federated learning, optimizing, reasoning. And so if you like try to understand TensorFlow in a way, right, like it gives you that full framework where you can easily do it and build and manage the model. And then naturally, if you go to the Red Hat OpenShift AI, it has all the like ingredients. So pretty much it is as simple. You create a workbench and select I need a TensorFlow workbench, and it will spin up all of the libraries, and then you can directly actually put and link the code. Don't forget obviously to link it with your S3 and in future your object or file store as well. So that is pretty much the whole story. I hope you get the sense, right, like how this framework works and then how you will apply it to solve a problem. So if you are like getting some value, don't forget to like, subscribe, and share. And thank you very much for joining in another episode, and we will come back with some more results later. Thank you. Bye bye.